Okay, so for the people who either want to watch us go over these problems again, or they're not here because they're writing a math contest, we're going to go over the questions for you to try that translate from base to base in different number systems, because we're going to quiz on this stuff next week. So the first problem is the one about Futurama. Bender's a robot, and like all computers, he speaks in binary code. He speaks in a base 2 number system. And in an episode of the show, they see this mysterious number here, 10100111010, and it scares him, and we're supposed to figure out why it scares him, and that's because we're going to have to figure out what it is in base 10. So now let's look at this number, 10100111010. Remember that in place value, this is always the ones place, so there's no ones in this number. This number, however, is not the tens place, it's the twos place. So this represents 1, 2. This number represents the fours place, so there's no fours. This number represents the eights place, so there is 1, 8. This number represents the 16s place, so I have to add a 16. This number represents the 32s. This is the 64s. This is the 128s. So there's a 128 in this number. This number here is the 256s. And this number here is the 512s. So there's a 1 times 512. So there's all of the numbers that actually have place value. All the rest are zeros, which means there's no value there. Those are just placeholders, the same way zeros hold place values in our regular base 10 system. So let's add this up. 8 plus 2 is 10. 8 plus 2 is 10. That's 26. 2, 3, 5, wait a minute. 2, 3, 4, 2, 3, 2, 3, 4, 5, 6, and 6, and aha! Clearly, the house that Bender's in is possessed by demons because the number scrawled on the wall in motor oil is 666. Next, Homer Simpson lives in a base 8 universe because, as anybody who's ever watched this cartoon knows, he only has 4 fingers. That's just something they do in most cartoons to keep the animation cheaper to make. It's just easier to draw 4 fingers than it is 5. So Homer lives at 742 Evergreen Terrace, and that number they're saying is a base 10 number. So this is a base 10 number. Sometimes we write that like this too. If I write it on the test or the quiz, I keep calling it a test. If I write it like that, there it is. It's a D. And sometimes we don't even bother with the whole word or the whole abbreviation. We just say that they're D. So that is a base 10 number, and we would like to convert it to something in base 8, also known as oct, or sometimes you even just see an O. Okay, so we have to convert it. So for this type of calculation, it's actually handy to have a list of bases of 8 and powers of 8. So I know 8 to the exponent 0 is 1. Then it's 8. Then it's 64. So now I'm up to 8 cubed, which is 512. And that's big enough. I don't need a bigger number than that because notice the number I'm going to is as big as 742. So when I look at the number 742, I ask myself, what's the biggest power of 8 that's in this number? And the answer is right here. There's a 512 in it. So in the 512's place of this number, there would be a 1, 512. So now I take the 742 and I take away the 512. 2 minus 2 is 0, 4 minus 1 is 3, 7 minus 5 is 2. That leaves 230. Now, here's the toughest part, especially since I'm working without a calculator. I'll get the people in the class to help me to make sure I don't goof this up. I need to figure out how many 64s are in this remainder of 230. Now, I think the answer is 3. Are we right about that? Yep. They're shaking their heads yes. So we probably have a 3 in the 64's place of the number. So 3 64s, I'm going to have to work that out. 3 64s. 3 times 4 is 12. Carry the 1. 3 times, so 192. Somebody double check that I did that right. So there's 192 from the 64's place. 10 minus 2 is an 8. That's now a 2. 12 minus 9 is a 3. Carry that. That's now a 1. So there's 38 leftovers. Make sure I did that right. This is just scrap work. Let me get it out of the way. So I'm now at the eighths place of this number. How many eighths would I find in the number 38? For sure, I'd find 4 of them. So there's 4 for a value in the eighths place. 38 minus 32 is 6. And that just leaves 6 in the ones place. So this number in base 10 translates to 1, 3, 4, 6 in base 8. So the answer is 1, 3, 4, 6 in base 8. Next, Nightcrawler would live in a base 6 universe if he had his way, because he has 6 fingers when you count 3 on each hand. And his first appearance was in the year 1975 in our base 10 system. So what would that look like in base 6? Just like the last example, it's really useful to have a list of powers of 6. So, of course, 6 to the 0 is 1. 6 to the 1 is 6. 6 squared is 36. 6 cubed is 216. And 6 to the power of 4 is 1296. And I can stop there because the next power of 6 would be way bigger than 1975. So how many 1296s are in 1975? Well, again, one of them. So 1975 minus 1296. Okay, I better be careful. I got to do lots of borrowing. That's a 6. 15 minus a 6 is a 9. 16 minus a 9 is a 7. 8 minus 2 is a 6. Double check that I did that right. And now I'm trying to think of how many 216s go in that number. So I know my next place value. Well, let's see. 200, 400, 600, and 316s is smaller than 79, so it is definitely 3. So I have 3 in the 216s place. Okay? So 3 times 216 is 648. Double check my mental math, guys. 9 minus 8 is a 1. 7 minus 4 is a 3. Now, this hasn't happened to us yet. The next place value is the 36's place. But I don't have 36 more number to take away. What that means is I need a placeholder. There is no number in the 6 squared place or the 36 place. Okay? Just like if you're writing a number, say that you were writing this number, but it was 5 years earlier. You'd write 1970 because there's nothing in the ones place. Well, in this case, there's nothing in the 36's place. So that means I have to look at this number and say, how many 6's do I have? Well, I have 5 of them. And that leaves me with 30. And then 1 left over. So my number is 13051. And that is a base 6 number. Okay? So that's number 3. Lastly, what if we have a base bigger than 10? We watched a cartoon about little 12 toes. He also has 12 fingers, so he wouldn't count by 10s, he'd count by 12s. Now, we need to agree on what our actual symbol is going to be for the numbers 10 and 11. If you watch the cartoon, I think it was Ek and Do. Do look kind of like a weird X. I'm not so good with those. Have I got them mixed up? Hannah thinks I've mixed them up. It might be. Okay, I know what I don't remember. I like the idea of doing what we do in hexadecimal. Let's just use A and B if we need them. If we need them, we may not even need them. But basically, for those of you who don't remember this, if you were counting in this system, you'd go 0 for nothing, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. And since you still aren't starting at the next place value yet, you need a symbol that means 10 and a symbol that means 11 in our base system. So, keeping that in mind, I still need to do powers of 12. So, the first place is still the ones place. But the second place is the 12's place. The third place is the 144's place. And oh, I always get this wrong. What is 12 cubed? 7 something? 17 something? 1728? Is that right? Double check. 12 to the power of 3. Yep. Good job. And that's big enough. That number, the next power of 12 would be way bigger than 1973. So from the year 1973, I clearly need to take away one power of 12, or 1/12 to the 3, which is one amount of 1728. All right, 13 minus an 8 is a 5, 6 minus a 2 is a 4, 9 minus a 7 is a 2. Now, how many 144s do I have in this number? Looks like only one. Two of them would be too big. So I have one 144, right? So one 144, subtracted from here, 5 minus 4 is a 1, 4 minus 4 is a 0, 2 minus 1 is a 1. How many 101s, or sorry, how many 12s can I find in the number 101? 8 of them is 96, right? So I'd have 8 in the 12s place, and then 11 minus 6 is a 5. So then I have 5 in the ones place. So luckily for me, I didn't need any fancy extra symbols. I can represent this base 10 number with the number 1185 in base 12. Okay. Quick summary, that's what the answer should be for the 4 problems that you had. And I can check a couple of them using just the calculator that comes with Windows. The calculator that comes with Windows, I usually keep mine set to scientific, but if I go to View, I can go to Programmer's View, and you'll notice there that there is, right here, a hexadecimal, decimal, octadecimal, and binary calculator. Well, that can check the first 2 of my answers. The first number I had was, let's go to binary, and I had 1, 0, 1, 0, 0, 1, 1, 0, 1, 0. If I then just click change that to a decimal number, it gets me the answer. So we did that right. For the second one, we started with the decimal number 742, and we changed it to oct. And we got 1346. Now, the other 2, we don't have on this calculator the ability to check base 6 and base 12, at least not easily. But if you go online and search, there's plenty of places that Google can lead you to that has calculators that can switch to any base you decide you want to count in. So you can always check your answers if you're trying these at home. Good luck next week.